Hello students, today we are going to deal with the third chapter of module 5, that is nothing but introduction to advanced manufacturing systems, and the fourth chapter is nothing but the robots and CNCs. The CNCs full form is computer numerical control. So we are going to deal the contents which are involved in the syllabus, that is related to the advanced manufacturing systems as well as CNC in one chapter, and robots robots of different anatomy we are going to study in the fourth chapter. So we are going in this video we are going to deal with both the chapters, that is covering the two chapters of module 5. So myself, I am Santosh Kunnur, Assistant Professor, Department of Mechanical Engineering, Vivekananda College of Engineering and Technology, Puttur. Right. So first, to deal about the advanced manufacturing systems, first we should know the different key elements of a manufacturing system, or the CNC systems, which involves the basic elements. The first one is we are going to involve a system. System is nothing but an interaction of elements and devices for a desired purpose. We are going to use one computer for automation, so that is we are going to call it as a system. It is an interconnection of elements and devices for a desired purpose. To obtain a desired manufacturing product, we need an interconnection of elements that can be achieved by a system, so that the input can be given to a system and output can be expected from a system. So we are, in clear words, we are going to define it as it is an interconnection of elements and devices for a desired purpose or a task that you are going to perform in a CNC machine. Next basic element is a control system. Control system is nothing but an interconnection of components forming a system configuration that will provide a desired response. The control system is nothing but it controls the overall devices which are performing the different tasks. So the interconnection between those components can be achieved by a control system. So we have to monitor the movement of the different tools or the work table that is involved in a system, that can be controlled by the control system. So this clearly says that the control system function is an interconnection of components forming a system configuration that will provide a desired response. The desired response is given to the different components at a accurate time. At a correct time, we have to give the desired response for a system, for a component. So that can be achieved by a control system. The third one is the process. Right? Process is nothing but the device or a system or a plant under the control. That is nothing but the input and output relationship represents the cause and effect relationship of the process. The process is nothing but right from the raw material to the finished good or the manufactured good that we need can be achieved through some different processes in the system. That is nothing but a process or a channel or a path to convert a raw material to the finished product. That is nothing but a process. So it is a device, a plant, or a system under the control. This process will be controlled by the control system that we have defined in the previous sentence, isn't it? So the process is simply, we can elaborate it with or explain it with one figure. The process is nothing but it is having the input and it is going to produce a desired output. So in the mechanical terms, the input we are going to call it as a raw material or a raw workpiece. So that raw workpiece we are going to process it according to the different dimensions, and again we are going to get a desired output, right, or a finished product or the finished workpiece. We are going to get one, not a workpiece, you can call it as a product. That is nothing but an output. Okay, we will move on to the next slide. We are going to move on to the next slide, that is the control system. What is exactly the control system? We can explain here. Control system includes the control is a process of causing the system variable to conform to some desired value. It is having a control. Control system will be having the control over the different components. So control is a process of causing a system variable to conform to some desired value. Control system controls the controls the components to have some desired values. So that is nothing but a control. We can have two different types of controls: manual control and automatic control. For anything involving machines only, for a simple example, I am going to give a manual control system, like the four-wheeler which is having the gear lever. That is a manual control system. Or automatic control system is nothing but without the gear. The four-wheeler or the car which is without the gear, or we can, in common terms, you might be knowing that the vehicle without the clutch, we are going to call it as automatic control. That is a big difference that you are going to observe it in a day-to-day life. Then next one is a control system. As we have already defined it in the previous slide, it is an interconnection of components forming a system configuration that will provide a desired system response. So that one we have explained. So the another figure which defines the control system is nothing but we have an input signal and output signal. We can expect it in terms of electrical signals. So we are going to control that system. We are going to give the energy source, isn't it? So that is about the control system. Next we are moving on to the next slide. Next is the basic components of a NC system. This is very important for your syllabus. The question may be you may be asked with question on this basic component of the NC system. NC system is nothing but it's a numerical control system. Here we will be having a set of program instructions in the machine language. So that program instructions we are going to feed it to the machine control unit. So the machine control unit is responsible to read that program, right, and understand the coding of the program, and again it is going to do the necessary actions or the controls in the machine. So we can expect the machine in a 2D diagram, that is there is a spindle and there is a tool, so that there is a work table, so that different operations can be carried out in a machine. The machine may be any machine, like a CNC lathe machine, CNC milling, CNC drilling, whatever it is. So we are going to assign this machine to any form, and again we are going to feed some set of program instructions to machine control unit, and again it is going to perform in the machine. That is a basic component of NC system. So the basic first component is a program, second component is a machine control system, and third one is a machine. Next we have an open loop control system and a closed loop control system that we have to study. Open loop control system is nothing but it is a control system where we can expect without the feedback loop. There is no feedback loop for the open loop control system, but for a closed loop control system we expect the feedback signal from the output. So in a clear words we can define the open loop control system as the input is not dependent on output, but output is definitely dependent on input, right? So that is the open loop control system. So for different elements of open loop control system we can see here, right? First we are the input parameter, we are going to send it to a controller. As we have already seen, this controller will read the input parameter what has been given, and again it is going to give for the actuators. There are different types of actuators present in the machine, maybe electrical actuator, electronic actuator, and again the mechanical actuators are there in the machine, so that this control system or controller is going to send signals to actuator to perform its function. So function we are going to expect in the form of a process, and again we are going to obtain an output variable. So it includes controller, actuator, process, and a output variable. So for a simple example we can take for an open loop control system is here. So we can take the simple example of iron box that we are going to use it in day-to-day life to iron our clothes. So here we have a timer as a controller. You have a timer as a controller. Actuator is a heating element or a heating coil that we are going to use it in a iron box, and process is nothing but the clothes. So we are going to explain it clearly. That is a desired amount of time we are going to send the input. What is the input for the iron box here? Input for the iron box is nothing but the electrical energy. For up to some input of electrical energy is going to heat for desired amount of time. Then after that it is going to give an indication to a timer, that is a controller. That timer, what it does, after heating the coil for a prescribed amount of time, it is going to switch off the electrical energy. Supply of electrical energy will be switched off from the timer whenever it hits the heating coil. Then that becomes the controller. Now that heating, that timer, again we are going to send it to an actuator, that is a heating element. If that heating coil indicates that a desired temperature has been reached by the coil, then it is going to send, the timer is going to switch off the electrical energy. That is the heating element, is the output or the actuator here. And again that heat we are going to transfer it to clothes for the processing. So whatever we have a process here, that heat which is generated by the heating coil, we are going to move it on a cloth so that the cloth will be obtained in a desired manner. That is the process, and actual dryness we are going to get it at the outset, isn't it? So that is the best example for a open loop control system. And another example for open loop control system is utilize a controller or control actuator to obtain the desired response, the same as that of the previous, that is desired output response. It will actuate the device and process it, and the output will be obtained. In a closed loop control system, as I have already said, there is a feedback loop for a measuring of output signal. So it utilizes the feedback to compare the actual output to the desired output response. So one of the simple example or simple elements we can see for a closed loop control system, that is the desired output response. We are going to compare it. The comparator is the main key element here. Then we are going to go for a controller. Then we are going to go for a process, and again we are going to produce the output. But before going to the output, there is one measuring element. That signal we are going to send it to a measurement. That is nothing but a feedback signal. Again it is going to send that signal to the comparator. So in this this is the feedback loop, which is very responsible for the closed loop control system. The output from the process signal, and that signals will be going to go through a feedback signal to a comparator. It is going to compare the next input signal with this output signal, and again necessary changes can be made in the comparator. That is the different key elements we can expect in the closed loop control system. Here multivariable control systems are there. That is the many signals can be sent at a single stretch. Desired output response, controller, process, and output variables. All these different signals will be having different outputs. So those feedback signals, or the individual feedback signals from the different outputs, will be given to measurement, and again individual signals will be sent to the comparators. So the multiple we are going to call it as a multivariable control system. That is not there for your syllabus, but just for your understanding purpose I have defined it. Then some of the examples of a open loop control system we can see here. It is a missile launcher system. Here we have a remote location, that is a programming element. That from that we are going to send a control signal to a power amplifier. From that power amplifier we are going to amplify the signals, and again we are going to actuate the motor actuator, and process can be done through launching a missile. That is nothing but a open loop control system, missile launcher system. Very simple example. So we won't expect a feedback signal here. If there was a feedback signal, what it does, whether the missile is launched or not, that signal we are going to get it at the comparator. But here it is not there. Since it is open loop control system, only the missile will be launched here. Then the second example of a closed loop feedback control system here is, we are going to give the feedback signal, as I have already said. The same missile launcher system, the remote location is here. Control signal we are going to send it to a differential amplifier. This will this will identify the errors in the previous signal, and again that error we are going to give it for a power amplifier. From the power amplifier, the desired amplified signal will be sent to a motor, and again the motor or the actuator will launch this missile to a desired distance. That output signal again we are going to take it through a feedback, and again we are going to give it for a differential amplifier, right? So this is about the missile launcher system based on closed loop control system. So the manual versus automatic control. In manual control, the control is a process of causing a system variable such as temperature or position to confirm the some desired value or trajectory called a reference value or trajectory. For example, driving a car implies controlling the vehicle to follow the desired path to arrive safely at the planned destination. If you are driving the car yourself, you are performing manual control of the car. If you design a machine or a computer to do it, then you have a built-in automatic control system. There's a very simple example of manual versus automatic control, right? We are going to take a example of a car, right? So that if you are driving a car right from the your location to a desired destination, then if you drive on your own, then we are going to call it as a manual control system, so that you are going to control it through a steering. But if you design a machine or a vehicle which works on its own, okay, you should switch on the machine and you should sit in your desired location, and again for the desired destination, it is going to take you on its own, so that it is going to follow the path that you have mentioned. So that is nothing but automatic control system. Then we have various control systems in the human system or human anatomy. This is just for your understanding purpose, not there in the syllabus. Now we are going to take pancreas, which is regulating blood glucose level. That is a control system. Adrenal automatically generate to increase the heart rate and oxygen in time of flight. And eyes are there as a control system, follow moving object. And hands are there to pick up an object and place it in a predetermined location. And temperature is there, that is a regulated temperature of 36 to 37 degree Celsius. Okay, the temperature that we are going to regulate for a human body is 36 degrees Celsius to 37 degree Celsius. That is also control system in the human system. Next one is the control system components, that is system, plant or process. These are the different key elements to be controlled. And actuators, what it does, converts the control signal to a power signal. In the actuator, we are going to convert the control signal to a power signal. And next is the sensors, provide measurement of the system output. There are various types of sensors that we are going to use it in different machines. So that provides measurement of the system output, and reference input represents the desired output of the process. Then general control system we can see here. Quickly we are going to glance over these general control systems. So here we have a set or a reference input. So we have a comparator here. This is used to compare the feedback signal with the input signal, and that error value we are going to send it to a controller. And here that controlled signal, that desired signal, we are going to send it to an actuator. That actuator, it is going to send the signal to a no disturbance should be there here. A manipulated variable will be sent to a process, and that process is going to be done, and again actual output we are going to get it at the other side. That actual, or before the actual output, that signal will be taken through a sensor, and that is a feedback signal, and again we are going to send it to a comparator. So this is a general control system that we are going to see here. This is the same thing what we have discussed till now. And again this is a feedback signal, and this is the closed loop control system. And then there is a subject called as mechatronics. This is also out of syllabus, just for your understanding purpose. This mechatronics includes the various things, that is sensors and actuators, physical system modeling we are going to have, and signal and systems, that is a control systems, we are going to have it in a mechatronics. Computer and logic system, and software and data acquisition. These all things is interrelated or correlated with one another. That complete structure forms the subject of the mechatronics, which includes the combination of mechanical plus the electronic system. Then we are going to look for a quickly glance over the different modern control systems which has the feedback signal or the closed loop signals. Right here we have a desired course to travel, and comparator, error, we have a driver, we have a steering mechanism, we have an automobile, and we have output and measurement, visible and tactile. We are going to give it as a feedback. First one, automobile steering control system. Here in the controller we have a driver, so he is going to actuate the steering mechanism, whether to go left or right. That can be done by a driver, and the driver uses the difference between the actual and the desired direction of travel. So he is going to identify the actual direction of travel and desired direction of travel. You might be seeing in the roads that there will be a divider, right? You should go in this path only. So the actual direction of travel is like this. So the desired direction, he has to follow it in a correct order. He can't come in near the white line, so that there will be an accident. So the desired direction he has to follow to generate a controlled adjustment of the steering wheel, so that he is going to adjust the steering mechanism and we are going to drive the vehicle or the automobile. Typical direction of travel response. So the typical direction of travel response can be achieved by the steering mechanism. If he is going correctly in a right path, then the measurement of visual and tactile is going to send a signal to the comparator, and input and feedback signal will not be having error. Always we need to maintain this error as 0, right? So that the driver is should control this error value. He should make it 0. That is the example of modern control system. The next one is a negative feedback system block diagram depicting a basic closed loop control system. The control device is often called a controller. This is also an example of a closed loop control system. Here we have an input desired value, we have a controlling device, we have actuator, we have a process, and the output we are going to expect here. That output signal through a feedback signal called as a sensor, we are going to measure it in a comparator. So this is also one of the closed loop control system. Then you can observe a figure, a manual control system for regulating the level of fluid in a tank by adjusting the output device. The operator views the level of a fluid through a port in the side of the tank. So this is a very simple example, so that the fluid is going out through a valve, right, and the fluid is coming inside the input. So the observer is going to look for a fluid level which is there in the tank, and again he is going to operate this wheel. That is also a modern control system, right? So that if the fluid level goes down, he is going to off this one. If it is go on top the level, he is going to switch on the valve. So that is about the modern control system. Next one is the machine, computer controlled machine, a 3-axis control system for inspecting individual semiconductor vapors with a highly sensitive camera. So the manufacturing of semiconductor vapors, we are going to look here. So that manufacturing can be observed through a highly sensitive camera. This is also an example of a modern control system. Next one is a coordinated control system for a boiler generator. This is also a best example for a modern control system, so that the water level in the boiler can be identified in a computerized control. In a computer control, the fuel input to the boiler can be controlled through a computer. The air input through a boiler can also be controlled through a computer. All the things that we are going to expect in a steam power plant can be controlled with a computer. So this is a modern control system. Here you know that steam power plant we have seen in the first chapter, module 1. So when the water is going through the boiler, it is going to heat up. That steam we are going to expand it in a turbine. Whenever we expand it, that turbine shaft is coupled to the generator shaft, and it is going to rotate, and it is going to generate the electricity. So this speed governor, pressure measurement, temperature measurement, oxygen measurement, valve opening and closing of air, valve opening and closing of fuel, valve opening and closing of feed water, all the things are controlled by this single unit, that is a computer, that is a controller. So this is the best example for the modern control system. Next one is a computer control system. Here also we are having a computer, as we are looking in a boiler generator. Here also we are going to have a computer. So instead of showing all these components, we are going to make it compact as the computer, actuator, process, and measurement. The same thing we are going to expect it in a computer control system. The future of control system. The future of control system is nothing but we are going to use the robots. We are going to follow the robots, so that the Honda P3 humanoid robot, this is the figure that you are showing, is a Honda P3 humanoid robot. P3 walks, climbs stairs, and turns corners. Turns the corners. Here can climbs the stairs, and he can turn the corners. All the functioning can be done by this robot. That is the photo courtesy of American Honda Motor Inc. they have given. So this is the humanoid robot which is developed by Honda, right? It's a Honda P3. We are going to call it as Honda P3 humanoid robot. Okay, then advantages of a CNC machines are CNC machines can be used continuously 24 hours a day, 365 days a year, and only need to be switched off for occasional maintenance. Okay, if you use a CNC system, if it is a machine, it is going to tire, right? Only thing we have to replace the components, we are going to switch it on 24 hours, it is going to work for whole year. So those are very advantageous compared to a manual system. Only when there is a maintenance you can switch off that. Then second point is CNC machines are programmed with a design that can then be manufactured hundreds or even thousands of times. Each manufactured product will be exactly the same. Say suppose if you want to manufacture pen cap, right? So desired program you are going to feed it to a machine, and if you can produce lakhs together, close together of pen caps of a pen, the same dimensions you are going to get whatever the program is installed previously. But whenever the same caps are made with a manual control system or a human labor, then there might be an error in the size and tolerance of the caps. So when you compare it with the human labor, CNC machines are much accurate compared to that of humans. Third one is less skilled trained people can operate CNC, unlike manual lathe milling machines, etc., which need skilled engineers. So you can use as unskilled laborers or less skilled laborers to operate the CNC. Okay, for maintenance of a lathe milling or milling machines to operate, we need highly skilled operators. CNC machines can be updated by improving the software used to drive the machines. CNC machines can be updated by improving the softwares. Okay, training in the use of CNC available through a use of virtual software. This is a software that allows the operator to practice using the CNC machine on the screen of a computer. The software is similar to a computer game. We can use this CNC machine through a virtual software, right? So the software is easy to operate, and the author is saying that it is as simple as playing a game in a computer. And sixth point is modern design software allows the designer to simulate the manufacture of his idea. Modern design software that is there it is used to simulate the manufacture of the idea, and one person can supervise many CNC machines, as once they are programmed they can usually be left to work by themselves. Sometimes only the cutting tools need replacing occasionally. So if you fed the program and switch on the system, that is okay, that is finished. Yeah, the programs according to the programs, the machine is going to run on its own till the work is finished. Later you need to replace the tool and you take out the finished workpiece. That is only the thing should be done by the labor. Then eighth one is a skilled engineer can make the same component many times. However, if each component is carefully studied, each one will vary slightly. A CNC machine will manufacture each component as an exact match, as we have discussed in the first point. If you give a components or the components to make by a human labor, there will be a variation in sizes. But when you give it to a CNC machine, locks together, cross together items or components will be having the same dimension. Then we have a discussion of a CNC Machining Center. Then we should know about what is CNC Machining Center. CNC Machining Center is advanced manufacturing machine tool which performs a wide range of machining operations with accuracy and inspection-free product with good quality of surface finishing. CNC Machining Center is nothing but it's an advanced manufacturing machine tool. It is a machine tool which is very advanced, which performs the many machining operations with correct accuracy, with correct inspection of a product, and good quality surface finishing. So if you manufacture a product by using the CNC Machining Center, no need of quality test, no need of inspection. So the surface finishing will be very good, and you should not inspect it again and again. So it will reduce the time. Kore. Next, we have accuracy and inspection of a free product with a good quality surface finishing can be obtained by a CNC machining center. Next, the operations done on drilling, milling and lathe can be performed on CNC machining center. The different operations that you are going to expect to be done in a drilling, milling and lathe can be performed on a single CNC machining center. Okay, so you can do it in a single CNC machining center, that is a CNC machining center. Then why we need a CNC machining center to be used? So if you go for a manufacturing of a prismatic components like a gearbox, okay, you can look for image of a gearbox, so that how complexity will be there in the gearbox. We have a bulkheads, we have a frames, we have a covers, etc. So those all things which includes the gearbox is very complex to manufacture, and it requires different types of operations to be done, like milling operation, boring operation, drilling operation, tapping and other many related machining operations are there in the gearbox. So those all things, drilling, boring, tapping, milling, all the things has to be done. That all things can be included in a single machining center. Say suppose if you have a different milling machine, boring machine, drilling machine, tapping machine and all, so we need to send those gearbox components to different machines to operate. So it increases the lead time, so that to take the component from one milling machine to go it to the to send it to the tapping machine, one labor has to lift that element components, and again he has to go to the desired tapping machine, and again he has to keep there, and again he has to set for a work table or set for a desired platform. But that increases the lead time, that consumes more amount of time. That time can be easily reduced by using the single CNC machining center. So CNC machining centers is were introduced, which made possible to do operations like milling, lathe, drill in a single machine tool. So it reduces a huge amount of lead time lead time as compared to that of different machines, isn't it? So machining centers are very useful. So that completes the chapter number 3. Next we are moving on to the next chapter, that is nothing but the robots. Next chapter is nothing but it's a robot. Robot is a very simple chapter. So you are already familiar with robots, right? You might have seen the movie of a robot of Rajnikant, where more and more many element of robots you can observe there. The name of the robot is Chetty, right? So those all things you have already seen in the movie. So the same thing, the anatomy of a robot, we are going to study in this chapter. The history of robot is the first. It is coined by a Czech novelist, Karel Čapek, in his 1920s play called Rassum's Universal Robots. So in 1920, the first robot was been developed in a Czech by Karel Čapek. He named it as Rassum's Universal Robots, RUR. Right? It's only a not a robot, it's a Rassum's Universal Robot, that is RUR. In Czech, the word robot means servant or worker. In Czech, they are going to call a robot, the meaning of the robot is nothing but a servant or a worker. Then the definition of robot is a reprogrammable multifunctional manipulator designed to move material, parts or devices through variable programmed motions of performance of variety of tasks. Yes, the definition of a robot is very simple. We are going to call it as it is having a reprogrammable function, and it is having a multifunctional concept, and again it is responsible to move the material, parts or devices from one place to the another place through a set of programs that is being given to the robot. So it is reprogrammable means the multiple programs or different programs we are going to add it to a robot, so that one program if you add it, then we can erase it, and again we can load the another program, and it is multifunctional. Multiple activities can be done in the robot. and again it is responsible to move the parts devices from one place to the other place, and it can perform the various variety of tasks. So robot is used in a multidisciplinary engineering field, in various engineering field for manufacturing production, where we are going to use this robots. The industrial robot is a general purpose programmable machine processing contain atmospheric anthropomorphic human life characteristics. We are going to call it as anthropomorphic. Anthropomorphic is nothing but it's a human like characteristic. The robots will be having the same characters as that of the human. Robotic arm is programmed to perform the task like production tasks, including machine loading, spot welding, spray painting, and assembly. The various tasks that is done by the human labor now, that will be replaced by the robots, because it is having anthropomorphic characteristics. It can do the same work as that of the human, like machine loading, spot welding, spray painting, and assembly. Robots are typically used as substitutes for human workers in these tasks. We can use the use as a substitutes for a human workers. Instead of human labor, we can use the robots. Next, the basics terms of industrial robot are, we have different terminologies of a robot, that is manipulator, joint, link, degrees of freedom, end effector, and base. We have a manipulator, we have a joint, we have a link, we have degrees of freedom, we have end effector, and base. We need to study about all these basic terms in the coming slides. The first one is the elements of a robot system. In the elements of a robot system, we have the robot consisting of manipulator, end of the arm, actuator, transmission elements. We are going to categorize in the robot. And in control system, we have a controls and sensors. And third one is we have a computer system. And fourth one is we need a power source to operate all these robot, control system, and computer systems. That is the basic elements of the robots. Then next is the sum of the qualities that make the industrial robot commercially and technologically important are listed. Why we are going to go for industrial robots rather than the human labors? That is hazardous work environment. Say suppose when the people are going to work in a steam power plant, right, they have to operate the boilers, right. The boiler, we are going to call it as a dangerous element. So it can, if it is working with some of the gases, right, so that is very dangerous. So at that hazardous environment like those, we can replace the human labors with the industrial robots. Then repetitive work cycle. Say suppose if I for an example, if I give you one task of opening the book and closing the book, right, very simple task. I'm going to tell you that now for complete 1 hour you should just open one page from the book, right. We have to rotate that page, and again you have to close, rotate that page, and we have to close, open, close, open, close. You should do it the same work, you should do it for multiple amounts of time. That is called as a repetitive work cycle. So what you are going to do, you feel very much interesting at the first, or to do that work for first 10 minutes. Okay, sir has given a simple task, we can do it. Open the page, close it, open the page, close it, open the page, close it. How continuously you can do it for 10 to 15 minutes. Okay, if you have a clear mindset that we have to do that work, so you can exceed that efficiency or accuracy of the work up to 20 to 25 minutes. Then what about the rest of 35 minutes? You feel bored of doing it, right? You feel very much bored of doing it, right? So what you are going to do, simply open the book, close the book. You have no interest, so simply for the namesake you are going to do it. So wherever you give a repetitive work cycle for a human labor, it is the accuracy or the precision will not be good. So if you give the same repetitive work for a robot, then you continuously for 1 hour it is going to perform the same operation, same output, same accuracy. We are going to get it for a complete 60 minutes. So that repetitive work cycle environment, where we have a repetitive work cycle, we can use the industrial robots. Then consistency and accuracy, as I have already said, in a repetitive work cycle, the consistency and accuracy will be very much good for an industrial robot. Then difficult handling task for humans, where there is a hazardous environments and difficult handling tasks, complex handling task for humans, we can replace it with the robots. Multi-shift operations, multiple shift operations can be done by the industrial robots. Say suppose if the human labor is working for 2 shifts in an industry, so one shift he can reduce and he can give it for the robots. We can work the robots in one shift, and in another shift we can give it for the human labors. Reprogrammable and flexible. Here in definition only we have explained the robots are reprogrammable. The program can be erased and rewritten, and it is flexible to do many tasks. Then interface to other computer system. It can easily pair with the other computing systems. The robots can easily pair. Next one, the simple robot construction. As I have said in key terminologies of the robot, it has a base, it has a link, and it has a joint. So you can have many amounts of link, many amount of joint for a robot. It has a base, link is 0, joint is 1. Here link is 1, right? Here link is 1, joint is 2, link is 2, and again we are going to have a joint and effector. So this joint and link, you can increase it to many number of times however you need, but that depends on the flexibility of this base. Okay, however it functions properly, the base functions properly, you can use the various amounts of joints and links. Then next type is should study about different types of joints. This is very important from the exam point of view. We have a rotational joint or joint. We have a rotational joint or joint, linear joint or the L joint. So we have a rotational joint, we have input link here, you have output link. This is joint motion. It can rotate in its own axis. So we are going to call it as R joint. Linear or L joint, that is having a linear movement. Input and output link will be moving right side and left side. Then orthogonal joint or O joint. Orthogonal joint is nothing but the perpendicular joint which has a 90-degree joint motion. You can move it like this. Input and output can be moved in a orthogonal or O type of joints. And twisting or T joint, input link is fixed and output link you are going to rotate. So that is nothing but the twisting or the T joint. In revolving joint or the V joint, we have an input link, we have output link. The joint, complete joint, input and in presence of input and output, we can revolve it. So it is called as revolving joint or the V joint. Next one, we have end effectors. For end effectors are nothing but the end portion of a robot. So it can hold the parts clearly. So how we can hold the parts clearly? That can be achieved by two types: mechanical gripper and vacuum grippers. Mechanical grippers are as simple as that of the things. So that we have 2 fingers here. 2 fingers are there. So that these 2 fingers, it can contract each other and it can relax each other. To hold an object, it is going to contract. To leave an object, it is going to relax. So that is called as mechanical gripper. The next one is vacuum gripper. Vacuum grippers are nothing but these are the cups which creates the vacuum. These cups, whenever you attach it to the outer body of the parts, it is going to create a vacuum and it is going to hold it. And whenever you want to release it, we are going to push the air and again it is going to release the parts. So these are the 2 types of grippers. We are going to use it as end effectors. And robot physical configurations, we have different physical configuration of a robot. So industrial robots come in variety of shapes and sizes. It has a different size, it has different shape. Based on the proper functions, we are going to categorize it into a different shapes and size of a robot. They possess different motion systems, and the physical configuration is responsible to possess different motion systems of a robot. So classifications of physical configuration we can see here. The first one is Cartesian configuration, second one is cylindrical configuration, third one is polar or spherical configuration, fourth one is jointed arm or revolve configuration. So we have a Cartesian configuration, cylindrical configuration, polar or spherical configuration, jointed arm or revolve configurations are there for a classification of physical configuration. First we are going to go for the Cartesian configurations. In Cartesian configuration, right, in a Cartesian configuration, you know that in Cartesian geometry we have x direction, y direction and z direction. So in the Cartesian configuration, the robots can have the movement in x direction, in y direction, and in z direction. Next direction means, so the link can be moved moved in front and backwards. In y direction, this end effector can be moved backwards and forward. In z direction, this height can also be adjusted. So this is nothing but the Cartesian coordination of a robot. Then this is a 3D view of a Cartesian coordination of a robot. Then the advantages of Cartesian coordination are high resolution and accuracy. It is there. No counterbalance problem is there in the Cartesian robot. Then 3 linear axes are there. Disadvantages are large structural framework cannot be stable, and complex mechanical design for linear sliding motions is very difficult, and confinement of the workspace is limited. So we need a more area to work for the Cartesian robot. Then for a cylindrical configuration of a robot, here it can have a rotation of a end effector in this and clockwise direction, and rotation of this end effector in the other direction, and movement of end effector forward and backwards in this direction. And here we have a rotational 360-degree revolving of a robot, and again we can increase the height and decrease the height of a cylindrical configuration. These all degrees of freedom are there for cylindrical configuration. Next, this is a 3D view of a cylindrical configuration. We can expect it can revolve up to 360 degrees. Then advantages are almost no counterbalance problem is there for a cylindrical configuration. Mechanical design is less complex than Cartesian robots. In a cylindrical configuration, you can view a JCB, right, or a earth mover that you are going to do. It can revolve all around 360 degrees, and 2 linear axis plus 1 rotating can reach all around itself. Disadvantages are large structural framework is there, lower accuracy compared with the Cartesian robot, and restriction of the workspace is there for this cylindrical configuration. And polar or spherical configuration, here we are going to give certain angle of rotation. It can move forward, it can move at a certain height, and it can go downwards. This is our radius of movement we are going to give it, and here it can revolve up to certain degrees. And L, that is, it can end effector can move forward and come backwards, and end effector can also rotate. So this is a polar configuration robot. This is the image, 3D image of polar configuration robot, right? This is also a 3D image. You can view the image of the polar configuration. Then the advantages are low weight and minimal structural complexity is there for polar configuration. Short joint to travel for many motions are there. Good accuracy and resolution can be expected in polar configuration. 1 linear plus 2 rotational axes are there for polar configurations. Disadvantages are large variable torque and second joint creating counterbalance problem. There is large variable torque is there for the polar configuration, and second joint is creating a counterbalance problem. Okay, and position error is large due to rotary joints. Position error is due to rotary joints. Jointed arm or revolve configuration, the configuration looks like same as the earth mover, right? Here we have a certain degrees of rotation. Here also it can revolve up to 360 degrees, and here also we can given one joint, and here also the end effector can revolve on its own axis. So the advantages are flexibility to reach over and under an object. It can reach over the object or under the object. Good workspace is there for this particular jointed arm or revolve configuration. 3 rotational axes can reach above or below the obstacles. There are 3 rotational axes can reach above or below the axis. 1, 2, and 3. 3 rotational axes above or below the objects can be reached. Disadvantages are counterbalance problem is more, poor resolution and accuracy due to rotary joints, high moment of inertia and dynamic instability is there for this jointed arm or revolve configurations. So the applications of robots, where all we can use these various types of robots First one is in material handling application. This is very important. Whenever you want to handle the material in industries, we are going to use these robots. That is transferring material from one location to another. That is pick and place robots we are going to call, and we are going to use this type of robots. And machine loading and unloading finished parts. Whenever you want to load the machine or unload the machine, we are going to use this robot. Then second one is processing operation. Whenever we want to process some functions, we are going to use this robots. That is different processes are spot welding, arc welding, spray painting, grinding, drilling, laser cutting. In all these processing operations, we are going to use these robots. Then the third one is assembly and inspection. To assemble different parts of a product either by fastening or joining process. Say suppose there are different individual parts are there, we need to assemble them. It is a similar process. We are going to program it for a robot, and all the parts it is going to take and it is going to assemble them. So different parts it is going to assemble for a product, and it is going to fasten it or it is going to join the elements. So that is the assembly process. And to inspect the quality of the products manufactured. If you manufacture a product, the quality of that product can be tested by the robots. So these are the various applications of robot. This is very important. This question can be asked in the exam. It is application of robots: material handling application, processing operations, and assembly and inspection. You need to explain it in detail. Okay, so this is about the application of robots, and this is about the complete syllabus of the robot chapter. And by this slide we are going to finish, or we have finished the complete module 5. So read well for module 5. The most of the expected question I have already given you during the explanation, and those questions you can refer and you can study. Thank you.